Step 6 is the most important part of this hydraulic calculation procedure because we are going to locate the remotest area. So as I already discussed in step 5 that we are going to consider the rectangular shape remotest area. We have to place this rectangular shaped remotest area away from the water supply and in a place that will be most challenging to get water to sprinklers that will open within our remotest area shape. So in fact we need to determine which sprinkler will be the most challenging to get water. So as from this drawing we can surely say that this will be, or we can likely guess that this will be the remotest sprinkler and most challenging place to deliver water to sprinkler. So this is the most challenging sprinkler for the water to reach. So now from step 5 we will take the area 1125 square feet is the area of operation, minimum area of operation we need to consider since we are using quick response sprinklers, and the length of the remotest area is 40 feet 3 inch which was already calculated in step 5. So length of the remotest area means we should draw this line from a far corner of the building. Here we are considering this sprinkler as the remotest. It is most likely to be the remotest sprinkler. So we need to consider the length of the remotest area from the far corner of the building. So this is the farthest corner of the building. So from here we need to check the dimension so that it should be 40 feet 3 inch. For example, if we see, I will just zoom it from here a little bit. Here if you see, this is 5 feet 14 feet and here we have 14 feet and till here it is 7 feet. So we are getting 28 feet plus 12 feet. So it will be about 9, 10, 3, 40 feet. But the length of the remotest area shall be 40 feet 3 inch. So till here it is only 40 feet. NFPA states that if this dimension 40 feet 3 inch or x or the length of the remotest area goes beyond the midway point between the sprinklers. See, already the sprinkler has crossed and 7 feet we consider. It goes beyond the midway point between two sprinklers. Then we must add an additional sprinkler to ensure that we meet minimum L dimension. L dimension we already determined earlier. So we need to consider this sprinkler as well to meet NFPA requirement. So this will be, actually it will be more than 40 feet 3 inch. So till here we need to consider because we are considering this sprinkler as well. So this will be length, already this one we mentioned as 52 feet. Okay. So now we'll move ahead. I believe you people are able to understand. So now we already know, just a moment, I will scroll it down. So length we already got 40 feet 3 inch, but actually this length shall be, revised length will be 52 feet. This needs to be considered. Please keep this in your mind. Then we already calculated that 9 sprinklers has to be considered for this design area of operation. This is a little complicated. You need to thoroughly check my video for your understanding purpose. If you miss any portion of my talk, you will miss the whole topic. You will not be able to understand. This is little bit complicated. You need to remember everything. So 9 sprinklers we already got from the earlier step. So 9 sprinklers has to be considered for this area of operation. Minimum shall be 9. So now we need to check. So already we consider 4 sprinklers, 1, this is 2, this is 3, and 4 sprinklers, and this will be 5, 6, 7, 8 sprinklers we consider. One more sprinkler we need to consider. Which sprinkler we need to consider? This one or this one or this one or this one. What nfpa 13 states? We need to go through that one. So 8 sprinklers, still 8 sprinkler we consider, but 9th sprinkler, which one we need to consider? So as per nfpa 13, for tree systems and loop systems, since we consider tree system, this is not a loop, this is a tree system. So the 9th sprinkler will be closest to the cross main. Please ignore my handwriting. So nfpa 13 indicates that the sprinkler closest to the cross main should be chosen. Okay, so this is the cross main. So if this is the cross main, then either this sprinkler or this sprinkler we can consider, since the what we can call the distance from this cross main is 7 feet for this sprinkler as well as this sprinkler. We will going to consider this particular sprinkler, this sprinkler. So I will just erase these things and we will move forward. Give me a minute. So you need to have a look at all steps to understand the concept of hydraulic calculations. Just because this is a big topic, I want to have a clear space. You have to make a notes for better understanding. Okay, so here I just clear this as well. This is not required now. So now what we will do, we will put some numbering on this for this 9 sprinklers. So I will just draw it here. This is one sprinkler, and this is one more sprinkler. This is other sprinkler 3, and this will be 4th sprinkler. From here the main line. I'm sorry, my straight line is not that much good. Just a minute, I will draw straight line. Okay, this is the riser. So here this will be, we will put numbers. Okay, later on we'll put. Okay, here we'll consider these sprinklers as well. These are the remotest sprinklers which we are going to consider, and 9th sprinkler which we are going to consider is this one. Okay, so the distance, I will just try to change the color. Okay, now we will put the numbering. Number 1, this, since this is most likely to be the remotest sprinkler, I am putting number 1 here, number 2, number 3, number 4, number 5, number 6, 7, 8, and this, since we are considering this one, so this will be the 9th sprinkler. So we need to consider 9 sprinklers. This is satisfied, but second thing is the area shall be minimum 1125 square feet as well, since we already calculated this one. Now we will check. I will take one more color just to put the dimensions. I'm just drawing here so that you might find easy from here. See, I am not writing the pipe sizes right now. Just I will write the distance. This will be 9 feet, this is 9 feet, and so on here also, since our consideration will be only these 9 sprinklers. And from the wall, just a minute, this will be the what we call the building outer dimension. So this is from here, the distance is 5 feet, and this is 4 feet. So now what we will do, we will just try to check the area of this particular, one second, this we try to check the area of these sprinklers initially, then we'll come back to this, and finally we'll check the area of this. Now I will take one more color. and yeah, this violet looks good. So now, since we already consider L as 52 feet, so we are going to consider this 52 feet, and here half of this 9 feet, we are going to get around 4 feet 6 inches. So the area will be this one. Just I will try to hatch. So the area for these sprinklers is, we call it as X. We will check later on. And this also from here till here, for this also half 4 feet 6 inch we need to take. So we will check this area as well. So this will be Y, for example, and now here you have a sprinkler as well. Okay, leave this one right now. So the sprinkler coverage for this area will be half. So it is already 7 feet here, 7 feet here. From here we take, and here also you have some sprinklers, right? So this is 9 feet, this distance. So we'll consider half of this. So here half and here half. Now here also you have sprinkler. So till 7 feet only we'll consider. So we'll hatch this portion as well. We'll make it this as Z. Okay. So now what we will do, I will take one more color. This is a complicated topic. You need to listen carefully. You have to go through couple of times to get a good idea. Okay. Now the area of coverage for sprinklers 1 to 4. So this one X we already mentioned, that is nothing but this is 52 feet multiply by this one. This will be, since already we have this one as 4 feet, and this will be 4 feet 6 inch. So total will be 8 feet 6 inch, which is equal to 442 square feet. Please remember this. And now we will calculate the area of coverage for sprinkler 5 to 8, which we mentioned as Y. So here, just a minute, we mentioned as Y. So that is equal to, this will also be 52 feet multiply by, so this will be 52 feet multiply by this distance. This distance is 4 feet 6 inch, 4 feet 6 inch. So it will be 9 feet. Okay. So now here we will write 52 feet multiply by 9 feet, which is equal to 468 square feet. Now the final sprinkler area will be 9th sprinkler, which is Z. We already mentioned here. So Z will be 126 square feet. Area of the sprinkler is same as area of coverage for each individual sprinkler. Since here we have 14 feet by here we have 9 feet. So 14 feet by 9 feet. Just a minute, I will 14 feet multiply by 9. Yeah, 126 we are getting. So this will be 14 feet by this will be 9 feet. So it comes around 126 square feet. Now we need to add X plus Y plus Z. So X plus Y plus Z, then we will get the design area which we consider up to now. So it will be 442 plus 468 plus 126. So we are getting about 1036 square feet. So 1036 square feet, which is less than 1125 square feet, which is the minimum design area of operation we need to consider. We have satisfied the condition of 9 sprinklers, but we did not, or we could not able to satisfy the design area of operation, which is 1125 square feet. So the difference is less, but it is less than our required area to comply with nfpa 13 requirements. So we must add sprinklers until we cover the actual area, which is 1125. So now what we need to do, we need to consider one more sprinkler. As I already told you, for tree system, the sprinkler must be considered which is nearest to the cross main. So obviously we will consider this sprinkler. I will put this as 10. So now we can hatch this portion as well. See, actually we need to consider 1125 square feet. Since by considering 9 sprinkler, we are not going to get 1125, we are only getting 1036 square feet. So that's the reason we are adding one more sprinkler which is nearest to the cross main. And now we will check whether, by considering this sprinkler, 10th sprinkler, whether this particular design area is satisfied to meet nfpa requirements. So now this area, as we already know, that this will be similar to, since the size is same, here we can say it as 9 feet, multiply by this one. The distance from here to here is only 5 feet, and from here to here is 7 feet. So 12 feet by 9 feet. It is about 12 feet by 9 feet. See, this will be 9 feet, and this will be 5 feet plus 7 feet. This will be 12 feet. 12 feet. Yes. So coverage area of this particular sprinkler, coverage area of 10th sprinkler is 9 feet multiplied by 12 feet, which is about 108 square feet. Now we will add this 108 to 1036. Now let us see. We don't have space. Just I am trying to create some space. We will take one more color meanwhile, and here I will take green color. I like green. So because you should not get bored, and this is the most important concept, so I am explaining slowly. So here we will do, or we will add the coverage area of 10th sprinkler 108 with this one 1036 square feet. This we got by considering 9 sprinkler. This is for the 10th sprinkler. So we are going to get 1144 square feet. So now again the design area has been changed to 1144 square feet. Actually the minimum required is 1125 square feet plus 9 sprinklers, but now this has been changed to 1144 square feet and 10 sprinklers. So now we end up with the revised design area as 1144 square feet. This will be the size and shape of remote area for our project. So if I say, or if just I will erase here some portions so that we can draw the remotest area here in this particular drawing. Just a minute. Okay, now it looks a little bit better. So based on this thing, this one will draw. See, this should be straight line. I am not having ruler, so I am just trying to draw a straight line. And from here, as per this, just check this drawing, and we just going to implement the same thing here till half portion of this will be covered by these sprinklers. So here we will put the noding later on, and half portion will be covered by these sprinklers. Just a minute. I don't have ruler, so I cannot draw straight lines properly. Anyhow, just try to understand the concept. So then we have drawn this 9th sprinkler, and finally, since the area not meeting the nfpa requirements, we consider this sprinkler as well. So now we will just put, I will take a red one, which is better. So 1, 2, 3, 4th sprinkler, 5 sprinklers, 6 sprinklers, 7 sprinklers, 8 sprinklers, 9th sprinkler, and this is the 10th sprinkler. So basically we consider 10 sprinklers. Now we will hatch with various colors. Just a minute. Here we already have green, so we'll try to take some other color. This looks good. So we will hatch this portion. So this will be X, as I already told. This area is 442 square feet, and then we'll take one more color like magenta. That would be better. So this area also we consider. Hatching just I'm drawing for our understanding purpose. So this will be, this area is 468 square feet, and finally we consider two things, two areas. 9th sprinkler. Okay, 9th sprinkler we got it as 126 square feet, so I'll just put it somewhere here, 126 square feet. And 10th sprinkler we got as, the area is 108 square feet. So we have added 442 plus 468 plus 108, or 126 plus 108. Then finally we got this 1144 square feet. This will be the size and shape. This portion from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sprinklers. This complete portion is the location of the remotest area. Most of the people confuse when they are going to select this 9th sprinkler. They might think this sprinkler has to be considered as 9th, but as per NFPA 13, we need to follow similar or exactly like this for the 9th sprinkler. So this will be the remotest area of operation with revised design area, that is 1144 square feet and 10 sprinklers. Okay, I hope you people understand this step 6. If you have any queries, you can just mail me, or you can just send your comments in the comment section, or if you need any further detail about this, just let me know, so that I'll be happy to share my knowledge with you. Thank you once again. Bye.